Hi guys, so we'll be solving an O-level past paper question from the year 2014. The session is October-November. This is question number 5. This question is based on circular measure. So let's start. The diagram shows the perimeter of a 400-meter running track. It consists of a rectangle measuring 100 meters by d meters and two semicircles of diameter d meters. The length of each semicircular arc is 100 meters. Part 1 says calculate d. In order to find this length over here d, you need to understand first that the length of each semicircular arc, that is this semicircle over here, this arc length is 100 meters. So what we do is our formula becomes arc length is equal to 2 pi r over 2. 2 and 2 can be cancelled out. So this becomes 100 equals to pi r. R is equal to 100 over pi. Let's plug this into the calculator. When we do this, this becomes 100 divided by 3.142. Okay, so the length of the radius becomes 31.8. Therefore, if we have to calculate d, you multiply 31.8 by 2. When we do that, d comes out to be 63.7 meters. So your answer to the first part is 63.7. The next part of the question says, calculate the total area of the region inside the running track. Okay, the region inside the running track consists of three different things. First of all, the rectangle that we have in the center, and then we have two semicircles at both ends. In order to find the area of the rectangle that we have in the center, you multiply d with 100. Okay, first let's write all of this down. Total area is equal to rectangles area plus semicircles, 2 times semicircles area. Okay, so the rectangle that we have to find, that is by multiplying 63.7 by 100, this gives you 6370 meters squared. And then if you talk about the semicircles can be found by multiplying pi r square over 2 by 2. Or you can simply cross these twos out and just find the area of one circle which has the same radius. Okay, so the radius that we found in the previous part, first we multiply 3.142 by the radius, which is 31.8 whole squared. When we do this, 31.8 times 31.8, 31.8 squared times 3.142, this gives us 3177. 3177 would do the job, yes. 3177 meters squared. Okay, when we do 3177 meters squared, this gives us Okay, so you add 3177, that's the area of the semicircle, plus 6370. When we add these two areas, you do 3177 plus 6370, and this gives you 9547 meters squared. That's the area of the whole shape. You round it off to three significant figures, so the answer becomes 9550 meters squared. Okay, the next part of the question says, the next part of the question says, S is the starting point and finishing point for the race, for the 400-meter race for a runner inside the lane. Okay, so S is when you go from this point all the way to this point, this is equal to 400 meters. A runner in an outer lane is always 3 meters from the inner perimeter. The runner in the outer lane starts at A, that means he starts at this point, runs all the way till T. And this length is also going to be 400 meters. And TS, the small part that we have over here, this is 3 meters. It has calculated the length of the arc TA. Okay, They're asking us to find the length of this arc TA. Let's figure out how to do that. First of all, what you need to understand over here is that A to T is 400 meters. All the way from this point all the way to this point is 400 meters. But in the middle, he has two stretches of 100 meters that are exactly straight and parallel to each other. So in order to find the arc length, what we can do is we can take out this 100 and this 100 from 400 meters so that our work becomes easy. I'll tell you in a minute. So you do 400 minus 200, so you're left with 200. Now this 200, if I further break it down and draw a circle, and in that circle I put the center as O over here, and I draw two radius A and T over here. Now this 200 that we get is the length of the major arc that we have in this circle. We need to find the length of this one. Now we already know the radius over here OT from the previous part. The radius was 31.8. Now since we know that the radius was 31.8, or instead we can do instead of this, what we can do is we can use the radius as 63.7 for a precise value. Now first we need to find the length, the circumference of the whole circle. So you do 2 pi r, and then you subtract the 200, that is the major arc length of this circle. So you'll be left with the value of AT. So you multiply 2 with 3.142 times the radius, which is 63.7 over 2, and subtract 200 from this. When you do this, you're left with 19.0 meters. The length from A to T, the length of the minor arc is 19 meters, so you write 19.0 meters over here. The next part and the last part of the question says, O is the center of a semicircular part of the track. AOT is what we need to find, the angle AOT. Okay, we need to find this angle that we have over here. This is very, very simple. First of all, try to understand something. If we need to find the arc length in this case, AOT or AT, the arc length AT was 19 meters. The formula for the arc length over here would be the angle AOT divided by 360 times 2 times 3.142 times, 3.142 times the radius. What is the radius over here? Let me see, 1 second. 63.7 divided by 2. 63.7 divided by 2 gives us 31.85. Let's use this. This is equal to 19 meters. Okay, so what we need to do next is AOT is equal to 19 times 360 divided by 2 times 3.142 times 31.85. When we multiply and divide all of this, AOT comes out to be 31.2 degrees. So your answer to the last part is 31.2 degrees, and we're done with the question. I hope this question made sense. The complete working of the entire question is present in the description below for you to download. If you like this video, hit the subscribe button, and thank you so much for watching.